Hello my friends, I welcome you all to my YouTube channel CosmiKodes. Today I am going to build a PCB for a DIY Arduino Uno board. Okay, so for that I'm going to go to the file, then new, then project. Here I'll name my project as DIY Uno V1.0. In the description I will add a dev board based upon 80 mega 328p dash pu. Okay, here you can see two files have been created, two blank files. The first one is the schematic file and second one is the PCB file. So for our PCB designing purpose, we have to build the schematic file first. So I am double clicking on the schematic file. Here you can see that we have been provided with a working space. Here we are going to place all the components. So first I am going to go to the components. Here I will search for 80 mega 328p dash pu. It will take some time, but you see that our DIP 28 version IC is here. So I'll place it over here, and after that I'll right click on the screen. So you see our component is placed. Now to select our component and to zoom in, we can use the mouse wheel. And to select our component, you see whenever I hover the mouse over the component, it is selected as red, and if I click on it, you see that the component is now selected. And if I hold and I left click on the component and I hold and drag the component, I can rearrange the component whatever I want. Okay, so the next thing we want is to place a crystal. I think we have to search it as 16 megahertz crystal. Okay, enter. I'll hit enter, and let's see what is the result. Yeah, I'm going to use this footprint. So I'll place the crystal over here. Okay, next I'm going to go to the components again. Here you can see there is a capacitor block here. So in the capacitor block there are ceramic disc capacitors, and in here I'll select this one. Okay, so we're going to need two capacitors. You see, when I hit the space button, it rotates the component. Okay, so I'm going to place the component like this, and another capacitor here. We don't need this text. Okay, and I'm going to rename it as C1 and this one to C2. Okay, next what we need is a ground port. So I'll place two ground over here. Okay, next we will provide power and ground to the microcontroller itself. So there are two ground connections here, and you see there is our 5-volt connection. Place it over here, and I'll connect the VCC and AVCC to our 5-volt terminal. Okay, next we have to go to the commonly library. Here I'll select resistance axial 1/4 watt through hole, and after selecting that I'll place one resistance over here. Okay, then I'll drag it, then I'll select the resistance, I'll drag it. You see there is a wire connected in between the reset pin and the resistance. Okay, now the another this terminal of the resistance will go to 5-volt like this. Next I'll copy this capacitor by pressing Ctrl C, and by pressing Ctrl V we can place the capacitor. Again I'm using space bar to rotate the component. Okay, so this capacitor is placed over here. Next what we need is a push button. I'll select this switch push button, and I'll place it over here. This button is for the reset purpose. To reset the microcontroller we're going to use this button. The first two terminals is going to be connected to ground, and the other terminal will go to the reset pin. So I'm not going to connect these two terminals to this terminal here physically. I'll use a bidirectional net port to fulfill the task. You see now I will copy this net port by hitting Ctrl C, and by hitting Ctrl V you see that a copy of the net port is placed to the reset pin. Okay, so what it means that this net port here, which I will rename it to RST, and also this one to RST. So by doing this this terminal is internally connected to this reset pin. Okay, so without any physical connection we have connected the reset pin together. Okay, this terminal is connected to this terminal here, this pin, without any physical connection. So this is net port. Okay, the next thing we want is a 2-terminal port, or a female port actually. I'll place it over here. Okay, the first terminal is going to be connected to ground. Okay, and the next terminal is going to be connected to 5-volt. I am designing this developmental board to be used with only 5-volt supply. So there is no inbuilt voltage regulator in here, so we must provide our microcontroller board with 5 volt supply. Okay, next I'll require one capacitor. I'll place it over here, and next I'm going to need one diode here, 14007 general purpose diode, and I'll place it to the positive and negative rail in the reverse configuration. So this will protect our circuit from reverse voltage. Okay, so next we will use another bidirectional net port to another net port, and I'm going to name this one as XTAL1 and this one as XTAL2. Okay, now I'm going to copy this XTAL1 and I'm going to paste it to this pin number 9. Okay, and this XTAL2 I'll copy it and paste it to the pin number 10. Okay, next I'm going to use the female header pin, a 6-pin port, and I'll place it over here like this. Okay, no, I think I'm going to shift the 5 volt to here and this one to here. Okay, now this 6th pin is connected to this terminal of the capacitor. The 5th pin is ANC or no connection, and the next one is, so this is our FTDI port to program the IC. So in the FTDI port, the first pin is the reset, this one. The next one is RX. So RX is going to be connected to pin number 3 of the microcontroller, and this pin is TX. So this is going to be connected to RXD of the microcontroller. Then I'll require another 5 volt. So this 5 volt is connected to this pin. Next this pin is ANC, meaning no connection, and the last one is ground. Okay, so this completes our schematic file. Now I'm going to draw some rectangles. You can also press Ctrl Z to undo the operation you have done. Okay, so this is our micro MCU, microcontroller unit. Okay, this is our programming unit or FTDI. Okay, this part is the power input. Okay, this part is responsible for resetting the microcontroller or RST, and this one is the crystal oscillator part. Okay, sorry, I'll place it over here. Okay, so now the last thing we need is some 6-pin header, female header pins for the input output pins. Okay, okay. So I think we are done. So I'm going to save it by pressing Ctrl S. And now the tricky part is here. We have to go to the design, then update or convert schematic to PCB. So after clicking apply changes, you can see that all the components are here. So in here we will build our PCB file. Okay, so first we have to rearrange our components so that everything is placed reasonably. Okay, so this is the tricky part. You have to be very patient as always. Okay, next so the crystal part is done, the input output ports are done. Okay, now the FTDI. Okay, next the resistance. The capacitor for the reset pin, the push button which is connected to reset pin, this is our input, power input section. Okay, okay, so our simple circuit is almost done. Now all we need is a board outline, so we have to go to this board outline section, and here you can see we can draw a board outline like this. And after that I'm going to save our circuit to this moment, and here you can go to the 3D block, and here you can have a look at the circuit in 3D. So everything looks fine. Okay, so now I'm going to go to the route and then auto routing. Here I'll unselect the top layer, and I'm going to go to the design rule. Here I will select the unit as millimeter, then I'll select the track width as 0. Say 5 millimeter, and okay, let's confirm, and let's run. So as you can see, our circuit is done, but there are some discrepancies here, so we have to route that these traces manually. So what I am going to do now is to delete this thing, and this is the ground trace. Okay, so I think I'll delete this one too. Okay, now we have to go to the layer, then I'll select the bottom layer as our traces are in the bottom layer, after which I'm going to select the this tool here, the single routing tool. Now I'm going to connect these traces first. Okay, now this one has to go. Okay, so this one is done, this one is done, ground, this one has to go for now. Okay, next this one. Okay, so we are progressing in the right direction. Okay, this part is done. Now I'll delete this one. Okay, See, this part of the PCB designing is somehow like solving a puzzle, and this is the trickiest part of the process. So you have to be very patient and cautious. Okay, next, yeah, this one, it has to go. Two, three, and four, and five, and six. So these are our six analog pins. It has to go. Hmm. Delete this one as well as this one and this one also. Next I'll place it over here. Okay. Okay, next the ground to the ground. This one is 5 volt. It is going quite well as of now. Okay, so I think we're going quite fast. Okay, yeah, now this ground terminal. Okay, so now I'm going to connect these two terminals here. Okay, yeah, so there is another way to connect this terminal. Okay, So I think our circuit is almost done. So the last thing which is required is to select the top silk screen layer, then select a text, and I'll select the height to 60, and I'll name the content as A1. Okay, so I'll place it over here. So this is our analog 1, analog 2, analog 3, analog 4, analog 5, analog 6. Yeah, 2, this one is 3, this one is 4, this one is 5, and this one is 6. Okay, the next thing is to place the text for these 6 pins. I'm using the Control V, as I have already copied the A1 text. Next I'll rename as D13, D12, D11, D10, D9, and D8. Next I'll copy this D8 by pressing Ctrl C, and then by pressing Ctrl V I'm going to paste it over here. Okay, so this is our D7, this is our D6, this is D5, 4, 3, and 2. Okay, next for the power pins, this is GND, and this is plus 5V. Okay, and I'll rename this as reset. Okay, so I think our circuit is done. So the final thing I'll do is to shrink the board size. Okay, and to increase the stability of our circuit I'm going to use a copper pore. Okay, so you can see there is an option called copper area, and I'm going to select the bottom layer, as I want to be the copper port in the bottom layer. So after confirm, you see that the unused area is filled with copper. So this will increase the stability of our circuit. So you can see that our PCB file is complete. So I'll hit Ctrl S and I'll save it, and you can see in the 3D diagram that there is our circuit. Looks quite good in such a short notice. So now I'll go to the file, then export, then I can generate the PCB fabrication file or the Gerber file by clicking this, and I can name it over here DIY Uno V1.0, and I'll hit export Gerber. I'll hit no continue on exporting. So you can see that my this file is the Gerber file. I have saved it on the desktop, and if you want the file to be exported as a PDF file, so you have to go to the PDF option. Here I'll rename it as bottom, and I'll select a single page PDF, and here I'll select only the bottom layer, and I'm going to increase the transparency to say 40%, and I'm going to export the file, and I'll save it. So you can see that there is a bottom layer PCB file which has been generated. Here you can change the transparency also. So go to file, then export, then PDF, and unselect all the layers except the bottom layer. Here you can set the transparency as 100%, and you can export. So you see, after saving it, you have the bottom layer file with the required transparency. Okay, next again go to file, then export, then PDF, then unselect all these options and select the bottom solder mask layer, and here select white on black and set the transparency to 0 and export. After saving, we have to rename it as mask, say mask, mask. And after hitting the save, you see that there is our solder mask file. So these two files are going to be is required for the PCB etching process, and you can use this Gerber file also to, you can provide this Gerber file to the PCB manufacturer, and they will print you the corresponding PCB. So I think you have learned something new today. So this is our this is for today's video, and I'll see you next time. Goodbye my friends.